Okay, so here program to apply EL algorithm. Program to apply EL algorithm to cluster a set of data stored in CSV file. Use the same data set for clustering using K-mean algorithm and compare the result of these two algorithms and comment on the quality of cluster. You can add Java or Python ML library classes API programs. So here you need to apply EL algorithm to a cluster of a set of data points that is available in CSV file, and also use the K-mean clustering for the same data set and compare those two. Okay, so this is the program for your lab using EM algorithm and K-mean algorithm. So we need to, so what are the steps? So here you can use the direct library, so no need to write the steps of that K-mean algorithm or EM algorithm. Everything is inbuilt. Just you can call that function, K-mean function. So that in that K-mean function, everything is available. That algorithm is available. Okay, so here we are, I start the lab. So here import matplotlib PUI plot as PAT. So that is matplotlib is used for, this library is used for, okay, graphic. When you want to represent a graphs, at the time this library is using matplotlib. We are importing that one from sklearn. From sklearn we are importing the data set. So here the CSV file is available in the sklearn. So inbuilt data file we are taking. Okay, so and from sklearn dot clusters we are importing K-mean cluster. Okay, so in sklearn clusters we are, from that we are importing K-means algorithm, that is K-mean clustering. And same thing, you know, import of pandas and import numpy. Okay, so this for numerical arrays, and pandas are used for data analysis. We are importing these two packages also. Okay, so here this iris dataset, one dataset is available in sklearn. This is most popular dataset. That one you will call it as iris dataset. So this is nothing but a flower dataset. Okay, iris dataset is nothing but it is a flower dataset. So in that we will have petal length, petal width, sepal length, sepal width. Okay, 4 attributes are there: petal length, petal width, sepal length, and sepal width. Okay, so here based on those parameters, we will classify that belongs to which category. So here in this side we have 3 different categories are there: Setosa, versicolor, and Virginia. Okay, so these are nothing but flowers. Okay, Setosa, versicolor, and Virginia. 3 different varieties of flowers are there. So based on that sepal length, sepal width, petal length, petal width, we will classify the we will classify the flower, whether it may be a Setosa or a versicolor or a Virginia. Okay, so here I am loading the data set, iris data set, and I am storing in this iris. Okay, then after that what I am doing, I am converting that one into a data frame. Okay, I am taking the data set, loading the data set. After that I am converting that data set into a data frame. Okay, that is 2-dimensional representation. Okay, whenever we want to do, we want to do some mathematical things, so we need to convert the data set into data frame. Okay, so then that one I will be stored. So here we are giving the name. So for a data set, so sepal length, sepal width, petal length, petal width. Okay, 4 columns are there. That is sepal length, sepal width, petal length, petal width. Okay, and that in the target we will have that is Setosa, versicolor, and Virginia. So these are the 3 targets are there. So that one I am copying to Y. I am making that one as a data frame. Okay, that one will be the Y, and I am giving the name as target. Okay, so now just nothing. We won't write any algorithmic steps for K-mean. Just we are calling that K-mean function. That's all. Everything is inbuilt. No need to worry. So in that program also they have told, okay, use API. Okay, so ML library or classes are API. So we are using this K-mean algorithm. So whatever the steps I have discussed, same steps it will be executed. Okay, so here I am calling K-mean algorithm. Okay, so I am building the model, K-mean model. K means, so number of clusters will be the 3. Okay, so here you can make it 2 or 3. So here, but in the target we have 3 variables are there, 3 different values are there: Setosa, versicolor, and Virginia. I will make a number of clusters will be the 3. Okay, so I am building the model. So here K means and number of clusters will be the 3, and I will fit the values to that model. Okay, so I am calling the K means by passing the number of clusters will be the 3. Okay, then I will fit the model by giving the values of the data set. Okay, the data set is available in X variable. I am fitting the model. Okay, so it will calculate all those things. Then after that, what I will do, I will be okay. It will calculate the, it will fit the model, or it will, model will be trained, and clusters will be, the data points will be make a 3 different clusters. So how we will see that one? So using matplotlib, we will represent a graph. Okay, so here this code is for to represent the the code is represents the clusters in x and y axis. Okay, so here the figure size will be the 1414. Okay, so that figure size x and x axis and y axis. So that whole thing should be 14 and 14. And here color map we are giving each value will be the red line and black. Setosa, versicolor, and okay, and Virginia. For all those things, we will give 3 different colors. Suppose the data point is belongs to Virginia, it may be red. Okay, the data points, it will be versicolor, it will be live, and data point it will be Virginia, it will be black. Like that, we are different colors we are giving. Okay, and we okay, so here we are giving title we are giving. The first we are creating the clusters. One is real clusters, another one is okay, so first one we are based on the data points, we are making a real clusters. Okay, and for x level, for x axis we are giving petal length, and y axis we are giving petal width. Okay, so x axis will be petal length and y axis will be petal length. Then after that we are displaying plotting the graph. Okay, so based on that scatters. Okay, x petal length, x petal width. Okay, color map model is equal to that is 40 data points. Okay, so here we are mapping, and we are giving the title. A K means clustering algorithm. We are giving the a title. K means clustering algorithm, and of x label will be the petal length and y label will be the petal width. Okay, so this is for real clusters. We are representing the graph for real cluster. This is the code for real cluster. This is the code for representing the cluster, k-mean cluster in this code. Okay, so we have represent that k-mean cluster also. We are represents the real cluster also. And now I will implement one more model, that is EM algorithm. Okay, so here the EM algorithm for Gaussian mixture model. Okay, so here what we are doing in Gaussian mixture model, so we are identifying the missing values. So automatically it will do. We are identifying the missing values, and we are using that the data will be distributed normally. Then after that we will use means and variance in this. Okay, so here same thing, we are import data will be pre-processing, that is for missing, identifying the missing values of all those things we are doing. So here we pre-processing that standard scalars, it will identify which are the missing values are there, we will identify, and after that we will fit the scalar dot fix, we will fix the model. Okay, so it means data points will be identified. So then after that we will transfer, we are normalizing the data points. So then after that what we are doing, we are converting that one into a data frame. Okay, so once this code is for pre-processing, so then after that identifying the missing values, then after that we are using, we are fitting, we are developing a Gaussian mixture model. Okay, so here we are importing the Gaussian mixture model. Okay, then after that here number of components, that is number of clusters will be the 3 in this Gaussian mixture model. So then I will fit the model using this data. Okay, so whatever the identifying, you say once it is normalized, the data will be fitting into the Gaussian mixture model. Okay, and after that I will predict the values. Okay, suppose if I give the petal length, petal width, sepal length, sepal width. So what is the flower? It belongs to which category? For identification also we are predicting, also we are doing in this. Okay, after that same steps we are using for representing the graph. Okay, so this is a Gaussian mixture clustering. So x-axis petal length, petal width, and finally, so usually, so when you have the observation will be the the EM algorithm is EM algorithm more efficient than k-means algorithm. Okay, so I will show the execution part. So I have executed all those things in Python environment. So you can use Google Colab also, or different softwares are available. Okay, so in our lab we are using Spider, and Jupyter Notebook also we are using. So here we are using, I am using Spider framework. So if you are not interested, not installed Anaconda framework, you can online you can go for Google Colab. That is also easy. If you want to execute, you can in our home also. If you don't have Anaconda framework, you can go for that Google Colab. Okay, so if I execute this one, so this is the run button. If I execute this one, okay, so here real clusters will be displayed, then after that k-mean clustering will be displayed, then after that EM algorithm, Gaussian mixture model is also executing. In this console the output will be displayed. It will take time. Yeah. Okay, so this is the real cluster. See here, the name is real cluster. Okay, so data is distributed. So we are giving depend Virginia, versicolor, and setosa, versicolor, and Virginia. So based we are giving different colors, red, lime, black. Okay, so these are the different colors. Okay, so this is the real cluster, the petal length. Based on petal length, petal width, we are making the cluster. Okay, and this is the second one. Okay, so this is the second one, petal k-mean algorithm. Okay, so this is the second one. It's not visible. Okay. Okay, this is the k-mean clustering. Okay, their data points will be clustered based on that sepal length and petal length and petal width. And this is the third one is Gaussian mixture model. Okay, so this is the third one, Gaussian mixture model. Okay, so like that data will be distributed, and we are representing the clusters. Okay, so usually this observation EM algorithm is more closely than k-mean. The data points in EM algorithm is more closely than k-mean cluster. You can observe, you may get this one. Okay, so data points are more close compared to EM algorithm. Okay, compared to k-mean algorithm, in EL algorithm, data points will be very close.